A very good morning to all of you. This session we will discuss on uninformed search technique AO star algorithm. We can start with an example. Suppose we want to build a mobile app. So is it possible to finish it in one step? No. So we can break it into different steps. UI design, backend and testing. So this is called a problem reduction. So problem reduction means solving a big problem by dividing it into smaller subproblems. So the main problem is solved when the required subproblems are solved. So we can say that in AI, we represent this type of problem using an AND OR graph. So we will see, first we will see OR graph, that is, OR means that is choice. Solving any one child is enough. So for example, we can say to reach college, I can go by bus or by bike or by car or by auto. So if one works, the problem is solved. So this is called a OR graph or node. And means and graph means all must be done. So every child node must be solved. So for example, we can say that for a lab integrated course, we know that in our college we have lab integrated course. So you must write the external examination for theory and also you have to attend the lab examination. So missing one, then you will fail. So all done means all completed means both completed means the problem is solved. So this is called a AND not. So by combining and or graph, so we can say that a real AI problem has choices, that means or, and mandatory steps, that means and. So, for example, we can say we are considering a house construction. So, or means when we are building the house, or means we can that means we can hire company A or company B, and means foundation and wall and roof. So that means here building a house, we can we can we can use the builders A or B, but in the case of when we are building the house, anyway we have to do the foundation, anyway we have to build walls and roof. So that is mandatory. And choose one company, that is or, and complete all construction stages, that is and. So a solution is not a single path. So it has a subtrees that can have or nodes and add nodes. Or for or nodes, choose one path and nodes include all children. So how we can decide which is a problem to solve first? For that, we can use best first search. So best first search always expand the most promising node first when using the heuristics. So for example, we can say that in Google Map, the routes with the least estimated time is explored first. So, which is a problem to be solved first, that will be decided based on the best first search. Here we will see the example. Here our goal is acquire TV set. So that is our goal, main goal, and we can divide into sub goals. The first one is steal TV set, second one earn some money, and the third one is buy TV set. So here we can see the first goal, steal TV set, means we reach the goal. So that is or no. Then next you can see earn some money. So that means earn some money means we didn't reach the goal state. We have to acquire TV set. So we have to buy TV set. So we can say that this is actually combined. Then only we can reach the goal state. So that we will represent using this arc. This shows and arc or and not. So for example, here you can see this A is the main problem and we are dividing into sub problems B, C and D. So here B is or not, we can the heuristic value is 5, and here you can see when you are solving C, the heuristic value is 3, but it is not complete. We cannot reach the goal state because there is an AND arc. So that means for solving this way, then we have to solve C and D. Then only we can solve A. So here solving A, the cost will be, here it is 3 and here it is 4, the heuristic value. And path cost we are considering it as 1. It is not given, that's why we are taking it as 1. So for solving going to C, the path cost is 1. For going to D, path cost is 1. So we are considering 3 plus 4, 7, 7 plus 2, 9. So for solving A, the total cost will be 9. That is 3 is the h of n of C, h of n of D is 4 and g of n of D is 1 and g of n of C is 1. We are taking the path cost as 1. It is not given, so we are considering it as 1. So it will be 2 plus 3 plus 4. So total 9. So we can choose this one. Here we require only 5 plus 1. The path cost will be 1 and the heuristic value is 5. So it will be 6. So we can select B. So that is the lowest one. So here in the next example you can see here A is the main problem. Here we have B, C and D. Here between C and D we can see one R. So that means if we are solving C, we have to solve D also. That means for if one child in the case of O, one child succeeds, then the parent goal is solved. But in the case of AND, all the childs we have to explore. So here you can see that for when you are solving B, then you can see then we have to solve E and F. So there is an R and R. So we have to solve E and F. So E, h of n is 5, F, h of n is 10. So it is 15. Then G of n here 1, here 1. So it will be 2, that is 17. 5 plus 15 plus 1 plus 1, it is 17. For solving D, the cost is 17. And then if we are solving C we have to solve G and H. G heuristics is 3, H heuristic is 4 and G of n of G is 1, G of n of H is 1. So total cost will be 3 plus 4 plus 1 plus 1, it is 9. And if we are solving C, we have to solve D also because here we have an AND arc. So for solving D, we have two child nodes I and J. There is an AND, so we have to solve both. So I heuristics is 15, J heuristics is 10. So it will be 25. Then we have G of n 1. Here also G of n 1. Then we have total 27. Then solving this, we can see that for solving C, we need 9. And for solving D, we have heuristic 27. So 27 plus 9, that is 36. Then here G of n will be 1, here G of n will be 1. So total 38. 36 plus 1 plus 1, that is 38. So, but here it is when solving B, we need only 17 plus 1, that is 18. So we can select B. B is the lowest cost. B has the lowest cost. Now we will see another example. Here, initially we have node 1, that is node A. Their heuristic value is 5. Next we are expanding A. Here you can see there are 3 children, B, C and D. For B, h of n is 3 and for C, h of n is 4 and D, h of n is 5. And there is an AND arc between B and C. That means if we are solving B, we have to solve C also. Then only we can reach the goal state. Then only we can solve A. But by solving D, we can solve A. So here we will see what will be the cost. B, 3 is the heuristic, h of n. C, h of n is 4. So this is 7. Then G of n will be, here we have 1, here we have 1. So that is total is 7 plus 7 plus 1 plus 1, that is 9. Then here it is an OR node D. D heuristic h of n is 5 and the path cost will be 1. So it will be 6. So we can select here. Here it is 6. So we can select D node. So we can expand D node. Next step we are expanding D node. In the D node you can see there are 2 child nodes. There is an AND arc. So we have to solve E and F. So for E, h of n is 5 and for EF, h of n is 4. So total it will be 8. And there is a G of n 1 here and the G of n 1 here. So it will be 1 plus 1, 2, 2 plus 8, that is 10. So for solving D, the heuristic value is 10. And 10 plus 1, that is 11. So here the heuristic value is 11. And then here you can see that B is 3 is the heuristic value, 4 is the heuristic value for solving C. So here the cost path is 1, here it is cost path is 1, so it is 9. So now this path is lower because this path is 9, and when choosing D, we need the heuristic value is 11. So this 9 is less. So again we are expanding B. So we are expanding B. B we have 5 and 7. Here you can see heuristics of G is 5 and heuristics of H is 7. So these are or nots. We can choose either of one. So we can choose this will be 5 plus 1 6. This will be 7 plus 1 8. So we will choose G because it is 5 plus 1, that is 6. Then we will see here we have and R. So we have to solve C also. So 6 plus 4, 10. Here is the path cost is 1. Here also path cost is 1. Total 6 plus 4, 10. 10 plus 1 plus 1, 12. So here it is. We can solve A by solving 12. And when you are choosing D, it is 11. So now this is the lowest by solving D. So we are again expanding E and F. We will continue like this. Here we will see the example. Here our starting node is A, and here we can see that the heuristic value is 8 before expanding the child nodes. Then we are expanding the child nodes. There are three child nodes B, C and D. There is an AND arc between B and C. So that means if we are solving B, we have to solve C also. So we can find the heuristic value. So here the heuristic value of B is 1, and C is H of n of C is 2. So here the path cost is also uh, given. It's given in the question. So for A to B, the cost G of n is 4. It is given G of n is 4. So, and the H of n is 1. So, it will be total 5. But we have to solve C also because there is an AND arc. So, C, the path cost is 5 and the heuristic value is 2. So, 2 plus 5, that is 7. So, here we have 7 and here we have 5. So, total it will be 12. 5 plus 7, 12. So, for solving we have to solve B and C. So, the total cost will be 12. Then if you are choosing D, so there is it's an or not. So here you can see for solving A to D, the path cost is 5. So it is 5 and the H of n will be 8. So 8 plus 5, it is 13. So we will choose the lowest is 12. So we will choose this path A to B and C. So now we are going to expand B. So here we can see the original figure also. From B you can see it is expanded to C. It is an OR graph. So we can expand C. We can go to C. C, H of n is 2 and G of n is 2. So it will be 2 plus 2, that is 4. So here we are updated the value 4. So now this is 4 and its G of n is 4. It is 8 here, and if we are solving B, we have to solve C also. So here H of n is 2 and path cost is from the figure we can see that it is 5 G of n. So 5 plus 2 it is 7. So total is 7. So 7 plus 8. 7 plus 8. These are and not. So we are adding these two. 8 plus 7, that is 15. Here it is 15. And this one we have already calculated in the previous step, that is 13. So this is more or less. So we are going to expand D. So we are going to expand D. So from the original figure you can see D is expanded to E and G. So now first we will see E. E we can see H of n is 1 and G of n is 2. So total is 3 actually. Here it is 3 and here it will be 0 and for G, H of n is 0 and G of n is 4. 0 plus 4, 4. So when we are comparing these two, 3 is less. So E is selected. E is selected. So then we are expanding E. So when we are expanding E, you can see that 0 plus G, it is expanded to G. Here h of n is 0 and path cost is 3. So it will be 3. So it will be 3. So 3, then the path cost from D to E, the path cost is 2. So it is 2 plus 3. This will be 5. Here the cost is 5. And here the total cost will be when we are going to from D to G, it is 0 plus the heuristic value is 4. From the original figure we can see. So 4 plus 0, it is 4. So this is lower and this will be selected. So then you can see from D is 4 means, and then D to A, the path cost is 5. We can see in the original figure. So it will be 9. So 9 is lesser. So we can reach the goal state by A to D, then D to G. So this is the lowest cost path. We can solve it using AO star algorithm. Here we can see the another example. Here we are starting from node A. And node A, we have three child nodes B, C and D. B is the OR node and C and D are R and nodes. Here we can see the R. So here we can calculate. Here the path cost is not given. So we are considering the path unit path cost, that is each path having cost is 1. In the previous question the path cost is given in the figure, but here it is not given. So we are taking the G of n of each node. We are considering it as 1. Then here we will see here we will see from A to B, the cost will be h of n is 4 and g of n is 1. So it will be 5. And here, if you are solving C, we have to solve D also because we have an AND arc. So here h of n for C, h of n is 2 and the path cost is 1. So it will be 3. Then we have to solve this also. For D, h of n is 3 and g of n is 1. So it will be 4. There is an AND arc. We have to add these two. So it will be 7. When comparing these two, 5 is more or less. So we are choosing A to B. A to B is chosen. So A to B we are choosing. Then after choosing B, then we have to solve the further nodes. That is, there are two children E and F. E and F. Where if we are going to E, the H of n is 6 and G of n is 1. So total it will be 7. And if you are choosing F, there is a H of n is 8 and path cost is 1. This is 9. So we are choosing 7. 7 is the lowest. So if this is 7, then the G of n is 1. So here the path cost, the total cost will be 8. And previously we have calculated it was 5. Now it is updated to 8. And here it was 7. So this is lower. And this one we have calculated in the previous slide by solving C and D. So it is 7. So here 7 is less. So we have to choose CD. So if you are choosing D, C, D also we have to choose because they are antarcts. So we are expanding C. So now we are expanding C. C, there are three child nodes. One is G, that is an OR node. H and I are AND nodes. Here you can see. Then if we are solving G, it is 2 plus 1, that is 3. Here it is 3. And if we are choosing H, it is 0 and G of n is 1. So it will be 1. And I, there is an AND arc means we have to solve I also. I is G of H of n is 0 and G of n is 1. So this will be 1 plus 1. It is 2. So when comparing these two, this is less. So solving C to H and I is less. This is 2. And so this is so then here CHI has the minimum value. Now if you are solving C, we have to solve D also. So D means actually here you can see that D to J, if we are considering D to J, H of n is 0 and G of n is 1. So it is updated to 1. And here it is 1 plus 1, that is here it is 2. And for C we have selected it as 2. So 2 plus 1, it is 3. So total this is 3 and 2. 3 and 2 we are adding, we are getting 5. So the cost is 5 and the path will be A, C, H, I, then D, A, D, J. This is the path. Because C and D are add nots, if we are solving C, we have to solve D also. Then we will discuss about the limitations of AO star algorithm. We have seen that what is AO star algorithm and how we can solve this algorithm. And we have discussed the examples also. Now we will see what are the limitations of this AO star algorithm. So here so far, we saw that AO star is powerful, but like every AI algorithm, it has limitations. We can see in the first figure, that is left figure, you can see that the shortest looking path is always the best. So this is not always true in AND OR gate. So here we can see that from A, there are multiple ways to solve the problem. One path looks shorter and another path looks longer actually. But the shortest path leads to the unsolvable sub-problems. So the longer path leads to the solution. So that means AO star may initially prefer a shorter or cheaper looking path, but later discover that is an unsolvable path. So that is the one problem. AO star must backtrack and choose longer but solvable path. So the local minimum does not always lead to a global minimum. We already discussed what is local minimum and global minimum. So heuristics can be misleading. Shortest may not be the best one. So that is why we have to. So here, this is the here you can see this may leads to a solution, but here the shortest path that leads to an unsolvable solution. So it's unsolvable. So shortest may not be the best one. We are always looking the shortest, and AO star must backtrack. And the second limitation, that is actually the second figure here. A is the main goal, and to solve A, we must solve C and D. There is an AND OR, so we have to solve C and D. To solve D, we must solve C or D. So here, the subgoals of C appear in two different places. That means subgoals are independent. So solving one subgoal affects the another one. You can see here C is the subgoal of A and also C is the subgoal of B. So that means subgoals are not independent and solving subgoal may affect the another goal. So here AO star assumes sub problems can be solved independently, but here solving C affect both A and D. So the cost calculation become complex and also the heuristic estimates may become inaccurate in this case. So AO star has difficulty when subgoals interact with each other. So that is the one problem here. So additionally, there are some problems are there. It requires accurate heuristics and high memory storage is required and repeated cost revisions. We have already seen in the example, there are repeated cost revisions are there and not efficient for large graphs. It may be complex in that case. So AO star works well when heuristics are accurate and subcalls are independent. So it will perform a poor performance if heuristics are misleading and subgoals are incorrect and also the problem space is. Now we will see the AO star algorithm in detail. This algorithm looks long, but conceptually AO star does only three things. Choose the best path, expand one node, update the cost backwards. So we will see. We will start with only the initial state. It will start with the init and no other nodes are known yet. Then if starting node is A, initially the graph has only A. Then we are keep running. Either the problem is solved or it is clear that the problem cannot be solved. So here there we have a value that is futility. That is a very large cost. Means useless to continue. So select an unexpected, here we have to select an unexpected node from the most promising path. So that means AO star does not expand random nodes. It follows the current best path from the init value. So it selects one unexpected node on that path. So that means AO star always stays focused on the best looking solution so far. Then generate the successors of that node. If there is no successor, means node is dead. Mark it as we can mark it as unsuccessor, unsolvable. Sorry, unsolvable. Then if then you can set h of node. Set the set h of that node is equal to is equal to the futility. So that will be, we are updating the futility. If not children, no solution from here. Then if the successor exists, then for each successor, add that node to the search graph. And if successor is a terminal one, then mark it as solved and set h is equal to 0. That means if goal node is reached, then h of g will be 0. Then if successor is not the terminal node, then computing purest value, just estimating cost to the cost to reach the goal. Then now A star updates information backwards towards the start node. S is equal to the nodes where cost or status changed, and then you can see that uh, we have to repeat until S is empty. That means remove a node from the current. So pick one node whose cost must be updated. Then we have to compute R cost. For OR node, take the minimum. For AND node, we have to take the sum. So we have already seen in the previous example, and we have to mark the best path. So highlight the arc with the minimum cost, then this becomes the current best path. So if all nodes required by its best arc are solved, then AND means we have to solve all the nodes, and OR means chosen child is solved. Then if current is changed, that means propagate upwards. We have to propagate it upwards. That means if our current is changed, then add its parent to S and repeat the update. And this is backtracking with the intelligence. Then final output of AO star. If AO star it does not return a single path, it return an optimal solution summary. Then we will see the advantages and disadvantages of AO star. Many AA problems are too big to solve directly. So we reduce a big problem into smaller problems. If we can solve all the sub problems, then the original problem is solved. So here an OR node means any one solution is enough. That means we already discussed to reach college or by bus or bike or train. So only one path is required. For the AND node means all sub problems must be solved. For cooking a dish, we have to buy vegetable and we have to prepare curry, and we have to add some salt and masala and all. So all steps are mandatory. So so we can say that OR arc means choose one, AND arc means solve all. So this is why it is called an AND OR graph. And here in AI, we don't want to explore everything blindly. So we use heuristic to decide which node looks more promising. So expand the node with the lowest estimated cost. So and here we are using H of n and G of n. So A star is basically the best first search algorithm. And here we will see the its advantages, that is it is complete. That is the main advantage. It is complete. If the solution exists, A star will find. And it works for both and or graphs, and avoids infinite loops actually. And then AO star, it uses less memory than exhaustive search and better than the brute force.
because it requires less memory, less space. Then time complexity is big O of b to the power m. M is the depth and b is the branching factor. And then the disadvantages means AO star is optimum if the heuristics is admissible. Um, but the heuristics error can be mislead. So complexity can be high, difficulty to design good heuristics, and also interacting subcodes cause problem. We already discussed the limitations. So we can say that AO star is powerful, but only as good as its heuristics. So AO star is a heuristic search algorithm used on Andor graph that solve problems by problem reduction method, expanding the most promising node first and constructing a solution graph instead of a single path. Thank you.